Hello and welcome to our College Algebra Section 3 notes. So this is our notes over outcome 3. So this will go with your third homework set. So in this section we're going to talk about slope, what the slope of a line is, slope between, a line between 2 points, finding the slope-intercept form, so we'll talk about slope-intercept form, and graphing some linear equations. So we're going to really get into lines, working with lines, graphing lines this section. Now just one thing I want to talk about at the beginning of the section is this definition or the difference between linear functions and nonlinear functions. We talked about functions last time, how functions you plug a value in for x, you get an output out for y. What we call a function a linear function if you graph the solutions, those xy pairs, and you get a straight line. So these are going to be equations that give us straight lines. A lot of times they'll have both a y and an x with no powers, or sometimes they'll just have a y. And so you might have something like this. This is a function that's just a y. That's a constant function we saw a little bit last week. Nonlinear functions, they'll still have a y and an x, but a lot of times you'll have like powers, like this one has x squared. This one you'll see an x on the bottom of a fraction, so that makes a weird function. And we'll see both of these actually later on in the semester. So we will see these curved nonlinear functions. But yeah, anytime you see a curve like this, it's not linear, not a straight line, it's a curve. And so we're going to deal with just straight lines today. Okay, first thing to deal with, if you make a straight line, diagonal line, horizontal line, stuff like that, if you make a straight line, you can always talk about the slope. When I think about slope, I always remember my high school math teacher that told me that if she taught me just the one thing about slope, then she didn't fail me as a math teacher. Like this is the one thing like I should remember forever after I get done with the class, and that was that the slope is the rise over the run. And that's exactly what slope is. It's a measurement of how much a line goes up, how much it goes up for a given amount of horizontal movement. So as you're going over, I always think about like driving up and down a hill with my car. That's how much you're going up the hill for every so many feet of going forward as you drive. So the slope on my line is the vertical distance over the horizontal distance. Now we can always find that distance between 2 points. I'm going to use this example down here. If I have my first point, x1, y1, and my second point, x2, y2, you can find the slope by taking and subtracting the y's, because you subtract the y's, so you're getting the vertical height. Remember that when you subtract, you're finding distance. So by subtracting y2, which is the second y, minus y1, we find the height, how much we're going up between the 2 points. And then I divide that by the run, which is going to be the difference of the x's. I'm going to take the x2 minus x1, and it's going to give me the horizontal distance. So x2 minus x1, and that's my horizontal distance. So this is our slope formula. You have 2 points. You have x1, y1, and x2, y2. You find the slope by taking the y's and subtracting them, and taking the x's and subtracting them. This slope formula is on your formula sheet. You'll notice that it's equal to m, because m is the letter for slope. I always thought that was weird. Why don't we use s for slope? And then I found out that in Greek, the word for slope starts with an m. So that's why m is slope. So m for us, m is slope, because back in the day, the Greek mathematicians did a lot of this stuff, and we use it now, what they used. So m is slope, and it's y2 minus y1 over x2 minus x1. Again, this is on your formula sheet, so you don't have to memorize that, but it's good to know what this is coming from. It's just taking the heights, subtracting them to get the rise, taking the x's, getting the run by subtracting those, and that gives you your slope. So if I give you any pair of points, you can just use the slope formula and find the slope. So I'm going to plug these in. So I'm going to call this first point x1, y1, and the second point x2, y2. And I'm going to plug in this equation. So I'm going to take the y2, which is 5, minus the y1, which is 2, divided by the x2, which is 4, minus the x1, which is a negative 3. So it's always subtract the y's, subtract the x's. So I got to simplify this a little bit. 5 minus 2 is negative 3. 4 minus a negative 3. Remember, when you have a negative negative, that's a double negative. It always turns into a positive. So 4 plus 3 is 7. So this slope here is my answer. It's negative 3/7. That's what we're going to put in my math lab. It's going to be our slope. That means this one is actually going down. That's why it's a negative number. It's going down 3 for every 7 you go over. So you go over 7 and go down 3. It's going to go like this. Try the next one. So I want to do the slope here again. I'm going to call the first one x1, y1, second one x2, y2. Put on our equation, we'll figure out what the slope is. So y2 is negative 2, y1 is 5, so I'm going to do negative 2 minus 5. 3 is my x2, so x2 I get 3, minus my x1 is 2, so minus 2. Well, negative 2 minus 5, remember when you subtract with negatives, you can always add the opposite, so I'm going to turn this into plus and turn this into a negative 5. So I'm going to think of this as negative 2 plus negative 5, and I get negative 7. And 3 minus 2 gives me 1. So this one is negative 7 over 1. It's going to go down 7 for every 1 we go over. This one's actually be pretty steep where it's down. Now, I wouldn't leave it like this, because this does simplify, right? You can take 7, divide by 1, you get 7. I would write this one as just negative 7. I like the fraction form, because now you can see the rise and the run, but I can write it as a whole number, because that's the best form to write this. It's simplified. And just remember that if you have a whole number for slope, there's always a 1 on the bottom. So this is just your rise, and you use 1 for the run. And this happens a lot. We'll use whole number slopes. Just got to remember the 1 on the bottom is your run. So if you have negative 7 for your slope, you need to go down 7 and then run 1, because there's a 1 built in. All right, let's try one more. I got these two values. I got 8, negative 3, so it's going to be my x1, y1. I got 8, 6, so it's going to be my x2, y2. And so I'm going to take my 6 minus negative 3, because I'm subtracting the y's, so 6 minus negative 3. And the bottom I get 8 minus 8. And the top, I got a double negative again, so 6 minus negative 3 becomes 6 plus 3. That's just 9. On the bottom, I have 8 minus 8, which actually gives me 0. We talked about this last section. We said that you can't divide by 0. That's not allowed. If I take 9 objects and try and put them nowhere, because dividing, you're trying to split it up into 0 groups, well, putting it in 0 groups means you have to put it nowhere. You can't do that. You need to have somewhere to put the 9. So this, we say, is not allowed. You cannot divide by 0. And we have a word for this. We call this undefined. This is undefined. Now, what in the world, how did 2 points give us this undefined slope? Well, if I think about what I have here, make a little quick, easy graph, and I look at this, I think that over here's 8, and I have 8, negative 3, so I'll go 8, 1, 2, 3, and negative 3, so there's a point here. And I go 8, 6, so 1, 2, 3, 4, 5, 6, and I have a point here. You can see the graph would make this a straight up, now I missed the 8, but you know what I mean, straight up and down line. And this is why it's undefined, because if you think about this, it's straight up and down. It's not a slope, it's a wall. This is something where if you're driving along, you hit this. You don't drive up the hill or down the hill, you just run into a wall. Vertical lines like this are always undefined. This tells us it's a vertical line. They're not really slopes. You know, this is the word we use. So if you ever have a vertical line, we say it has undefined slope because it's a vertical line. But again, it's not really a slope because it's not downhill or horizontal or uphill. It's a wall. It's just up and down. You can't drive a car on this. It doesn't really work very well. So that leads us to there's 4 types of slope. So we talked a little bit. We talked about negatives. We talked about undefined. But the first type of slope is actually the positive type of slope, like what we see in the picture up here, where it's going up to the right. You have a line that goes up to the right. We think of that as positive slope. It's because as you go to the right, you go up. As you go to the positive direction, you go up. That's positive slope. Next one we're going to have is going to be negative slope. And negative just means that as you go to the right, you come down. So as you go to the right, you're coming down. That's negative slope. So positive, negative makes it negative. The next one is going to be our undefined. Right? We said if you have a vertical line straight up and down, you can call that undefined because it's straight up and down, the vertical line. It's not going up to the right or down to the right, so we just say this is undefined. Now there's one more option. Well, if I'm not going up to the right, down to the right, or undefined, well, it could be horizontal, right? Horizontal is going to be the last option. And this is actually going to be 0 slope. Because as you go to the right, you're not going up, you're not going down, so you're staying constant. Staying constant, so your slope is 0, because you're not going uphill. This is flat. 0 is horizontal, it's flat. When I was in high school, we drove through like the salt flats of Utah. So I always think of when I think about horizontal lines, is it's just perfectly flat. Like it's just as far as the eye can see. There is no uphill, there's no downhill. It's just flat, and that's what it's like when you're driving through Utah. So those are our 4 types of slope. Positive means we go up to the right. negative needs to go down to the right. Undefined, it's a vertical line, and 0 is horizontal. So when I get these slopes like this, -3/7, -7, that tells me that those two lines, if I draw lines connecting those points, it'll look like this. The further your number is from 0, so the more negative it gets, the steeper the line gets. So this -7, which is a lot further from 0 than -3/7, because that's not even like -1. This number is going to be a lot steeper going down to the right than the -3/7 is. With positive numbers, the further you get from 0, the higher the number gets, the steeper it's going to go uphill. So a slope of 10 is going to be going uphill really fast compared to a slope of 1. So that's kind of how slopes work. So you should be ready to find slope on the test. We'll use slope a lot for the next couple sections, so you'll get pretty familiar with it. Okay, so I mentioned these linear functions. That's what we're working, right? We're making straight lines. Any linear function can be written in this form, where you have f of x equals mx plus b. Probably looks familiar, because most of the time when people write this, they do the same thing, but they call it y equals mx plus b. So this is what we call the slope-intercept form, which I'll have down at the bottom of the page, but that's what this is. Slope-intercept form. It's just a way to write the equation of a line that's going to be either diagonal upwards, diagonal downwards, or horizontal. This won't work for vertical lines, because note that vertical lines are not functions. We talked about last time that you have to pass that vertical line test with functions. This does not pass a vertical line test. You can draw a vertical line that crosses lots of times. The rest of these would pass a vertical line test. So any function that's going to be diagonal, upwards to the right, downwards to the right, it's going to be like that. It's going to have this kind of shape. In this equation, shape, you're going to have m and b are going to be numbers, where m is going to be the slope of the line, and b is going to be like where it hits on this y-axis. One example is if m is 0, so if the slope is 0, you'll get a horizontal line. So I'll just mark that off. So slope of 0, it's a constant function, which we call is that horizontal line. So a constant function right here because the slope is 0. So when you have slope 0, then it looks like this. If the slope is 1 and the intercept is 0, this b value is 0, so if the b value is 0, the slope is 1, we get what we call the identity function. We call it the identity function because with the identity function, every x and y match. So you put in a 1, you get a 1. You put in a 4, you get a 4. So this function, whatever you plug into it, you get it right back out. It's identical to what you put in. And so again, this is when the intercept is 0 and the slope is 1. So y equals x is what this equation looks like. That's the identity function. And it looks like this. It's a line that goes up to the right where every number matches. You -3, you get -3. At -2, you get -2. At -1, you get -1. So these are two pretty common functions. Constant functions can have lots of different heights. It all just depends on what the b value is, what the number where it intercepts on this intercept. The identity function goes right through the middle down at 0 and it has a slope of 1, and that's their y equals x. That's your identity function. Okay, so just by looking at the equations in these form, you can graph these pretty easily because they tell you a lot of information. So I see something like this, and again, the 2 is your slope. It's your slope, and the -4 here is the intercept. It's where it's going to cross this y-axis. So -4 is b. So I can graph this without using my t-chart or my calculator or anything like that. I can say, well, first off, -4 is going to be where it crosses this y-axis. So at -4, we're going to go right there. That's because if you put 0 in for x, you get 0 here, you just get -4. So you put 0 in for x, you get -4. That's the b value right there. And then you can use your slope. Now again, we got a whole number slope. Remember the whole number slopes, you can always think of them having 1 on the bottom. And remember the slope is rise over run. So I can just use this and I can count my slope. I can go up 1, 2 over 1 and say that's the next point on my graph. If I want more points, I can keep going. I go 1, 2, and count 1. Because rise 2, run 1. You can see that line is going to be your slope, your equation, this equation for this line. So go through these points. If I keep thinking about up 2 over 1, I can see kind of where I'm supposed to cross. There's 1 here, 1 here, 1 here. You can go backwards, right? You can go down 2 and back 1 because a double negative, negative down, negative left is a positive. So you can always go backwards. Down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. And you can see it goes like that. But that's the equation, 2x minus 4. because it crosses at -4 and has a slope of 2, up 2 over 1. So positive 2, positive 1, 2 over 1. So like this next equation here, we can graph this. Again, the intercept, so b, is going to be 3. That's where it crosses this y-axis, so at 3. Because if you put in 0 for x, that part goes away, you just get 3. And then the slope is the number in front of your x. Slope is just a number. We never use the x for slope, because slope is the number. So it's the -1/2. So my slope here is going to be -1/2. That means I'm going to go down 1 for every 2 I go over. Because of the rise over run, well, the negative, I'm going to count that as down 1 over 2. It's going to go here. Down 1 over 2, down 1 over 2. It's going to look like that. You can do this one backwards as well. You can go up 1, but then you have to go left 2 for the negative. So up 1, left 2, up 1, left 2, up 1, left 2. As long as one of the sides is negative, you're either going down and right or up and left, because left is negative, you end up with that same straight line. So it looks something like this. I'm not using a straight, it's just not going to be perfect, but it looks something like that. Okay, so that'd be the equation y equals -1/2 x plus 3. And you can write these again. You can write these equations with y equals or with f of x, because f of x just says function notation. Again, these are functions. They pass that vertical line test. So both functions. That's what they would look like. So you can just use that intercept, the slope, and get nice graphs of these. You could type in your calculator as well. They're f of x equations. You can always type functions in your calculator. Wherever it says f of x, you just use that as your y and type it in. So I'm going to do 2x minus 4 and then hit graph. And you can graph them like that. So you can get the graph just like that and see what it looks like. You can hit table, second table, and see the table of values for it. So all that works fine. But yeah, you can graph them without a calculator if you need to, as long as you got that mx plus b form. Again, we call this slope-intercept form. And it's really important because 9 times out of 10, if someone wants the equation of a straight line, they want it in slope-intercept form. They want it written like this, y equals mx plus b. A lot of times people will drop the f of x. They won't really write the f of x on these straight lines because they're really well known. And so most people see a straight line like this and they know right away. If it's a straight line, it's going to be a function. So you don't really need the function label. But you can write it with the function label if you want to. But don't be surprised if a lot of people write y equals f of x plus b, because that's just a nice way to say, hey, it's a straight line. Everybody knows what a straight line looks like. It looks like this or like that. And so we can tell it's a function and all that. Last thing, here we're going to do a question where we go backwards. So instead of giving us the equation and figuring out the slope and the intercept, they gave us an equation where they said, here is the slope, and here's the intercept, the y-intercept. Now figure out what the equation looks like. So this is just going backwards. Instead of using the equation to get that information, they gave us the information. So we can put this in. We just got to remember that the slope is m, and the y-intercept is b. So I can just take this y equals mx plus b and write this as y equals 1/2 x minus 8. Now I'm not going to put plus and negative 8 because my math app would not like that. They don't like plus and negative, so I'm just going to turn that into a minus whenever I see something where I'm like adding a -8. Since this is a -8 minus 8, we're going to put a minus there. And that would be in slope-intercept form. Again, if you want function notation, you could replace the y with f of x. I'm pretty sure my math app would be having a y. That's my guess. So that's most of the time what you'll see, because that's the more common thing. Okay, last page. So we're just going to take these equations they gave us. We're going to figure out what the slope and the y-intercept is, and then we're going to graph them. Now the first one looks a little tricky, because you'll notice right off the bat the x's are missing. Whenever this happens, when you have an equation y equals stuff and there's no x, it's because the slope is 0. In this case, the slope is 0. That's why the x is gone. If we wrote this out with y equals mx, well, m is 0, we'd have 0x plus 2, because there's the 2. We notice that 0 times x is nothing, and so it goes away, and that's why they just write y equals 2. This is what happens when the slope is 0. This is what happens when you have a horizontal line. So if you ever see y equals a number, there's no x at all, the x is gone because the 0 got rid of it. If the slope is 0, it gets rid of it, you get a straight horizontal line. Now, all you have to know about a horizontal line is how high to put it. So how high do I put this horizontal line? So if this is equal to 2, that's how high I put it. So we're going to put it up here at new. Now, I've gotten so many questions in the past, people using my math app to say, well, I only have this one point. How can I graph the horizontal line? Well, if it's a horizontal line, every point that's the same height is a point on that line. So you can use this one, or you could use this one, or 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 even points between, because all you have to do is make sure your height is 2, because a horizontal line, all the points that are too high are on that horizontal line. So if you ever get y equals 2, you can graph it using any of these points that are too high. Okay, now this next one is different because this one, instead of giving us y equals, they gave us x equals. The big difference here is now it's not a y equals equation, it's an x equals equation. Now what's this mean? Well, that means that instead of knowing how high this thing is, because we know y, we know how far over it is, because we know x. So this is over here at 4. So this is actually a vertical line. Anytime you have x equals number, that is a vertical line, which means its slope is undefined. Remember, so the vertical lines have undefined slope. So because this is x equals 4, because it's x equals and not y equals, this is not a nice horizontal line or diagonal line. This is a vertical line. This is a vertical line at 4, because x is 4, so I'm using the 4 on the x. And again, just like the other one, where I knew I could just go left and right as far as I want, here I can go up and down as I want. I just can't move left or right, because this is a vertical line. Every point that's straight up or down on this thing works on this line. That is the line x equals 4. One thing to note between the two, when I was first learning this, I always mixed up these two. Note that the y equals, you can graph, because your calculator has a y equals, so you can graph things like y equals 2 and see what they look like. And that'll help you remember that y equals are horizontal. But when you go to graph your x equals, well, there's no x equals. You can't do x equals because your calculator won't graph vertical lines, because your calculator only graphs functions, and that is not a function. So your calculator will graph these horizontal lines, so you can always double check those. If it's x equals, know that that's the weird vertical lines. That's why they have a weird undefined slope and all that kind of stuff, because this one is a vertical line. Notice that this one has no y-intercept. Because it's a vertical line, it's not going to cross the y-axis. It has an x-intercept, but no y-intercept. All the other equations we're going to deal with are going to have y-intercepts, but this one, being an undefined line, does not have a y-intercept. Okay, let's try a couple that are not weird like that. They're weird for other reasons. I just thought you were going to say they're normal. This first one's not that weird. All they did here is they just didn't write it down very nicely. Instead of putting mx plus b, which we're used to, they put the b in the front, because the number next to the x, that's always your m. So this one, you could rewrite this. If you don't like this equation, you can write it as negative 2x plus 5. Notice it's a positive 5, so it has to stay positive. The minus is on the 2, so it stays on the 2. And then that looks a little more familiar, right? This would be your y equals mx plus b. Now it's pretty clear the slope is negative 2 and the intercept is 5. You can see that here as well. You can see that the negative 2 is by the x, and the 5 is not by the x, right? It's off by itself. So you can still see that. But sometimes writing this equation in this form might help. Okay, so again, when we graph these, we graph the intercept. We see it's going to cross at 5. That's our intercept. And then we count our slope. Again, a whole number slope. Always have a 1 on the bottom when you need it. So there's a moth, of course. Sorry. They've been really bad here today. I had a ton of them in my house. I'm going to turn on the bigger lights because they went off. And that's why there we go. So hopefully I'll leave you alone for a second. Okay. This is not how you know these are real life notes, not like AI generated or something, because your teacher has to stop and fight a moth off. So here we go. Sorry. We're going to graph this. We graphed 5 for our intercept, and then we're going to use our slope. Because it's negative 2 over 1, I'm going to go down 2 over 1. It's going to look like that. Down 2 over 1, down 2 over 1. And that's what it's going to look like. So we can draw our line and get our equation's graph like that. Because it was a negative slope, it went down as we went to the right. Okay, last one. This one's similar. Again, they kind of messed with us a little bit. Here, they just messed with us by not combining like terms. We've got that 3, we've got that negative 5. They're both whole numbers. They're both numbers. We can combine those, right? So we're going to rewrite this. We do 3 plus a negative 5. It's going to give me a negative 2, right? Because there's more negative than positive. So this is really 2x minus 2. That's what this equation should be written as. You should always be able to simplify a straight line equation down to just something x and a number like that. So you can see the slope, in this case 2, see the intercept, in this case negative 2, because they're written out that way, for our mx plus b. But again, if they give you too many numbers, just combine like terms to make it work. So I graph this, I graph at -2 down here, count my slope, up 2 over 1, up 2 over 1, give me some points, and I know it's going to look something like this. And that's my last one. Again, positive slope, it goes up to the right. Okay, so that's what all we're doing for this section. We're going to be working with that slope-intercept form, that mx plus b form. You should be ready for horizontal lines or vertical lines. Again, vertical lines have that root of x equals. You should know which one's the slope, which one's the intercept, even if they do things like sit around on you. And you should be able to find the slope given any pair of points. You can always take a graph, find 2 points, and just find their slope using that y2 minus y1 over x2 minus x1. Again, this slope equation is on your formula sheet. And I believe I also have that mx plus b. So you'll see this, y equals mx plus b. That'll be on your formula sheet as well. So those will be there to remind you when you're taking the test and stuff. Again, I always recommend using that formula sheet when you're doing the homework and the quizzes, because then you'll be comfortable with it and you're ready to use it when you get to the test. That's our third outcome. That's your third homework set you need to be working on. We'll cover this material. Hopefully that's working well for you. So always, if you have questions when you're doing the homework, remember there's that Ask My Instructor button. It's a great way to ask questions because it gives me a nice email with all the information I need so I can answer questions. So make sure you're using that when you're doing the homework. I'll see you on the next set.